Assalamualaikum warahmatullahi wabarakatuh. Today I'm gonna talk about why the sky is blue. So, when we look up at the sky on a clear day, we see a bright blue color stretching in every direction. This color feels normal and familiar, but it is actually the result of several physical processes happening at once. The sky itself actually has no color of its own. What we see is actually caused by sunlight interacting with Earth's atmosphere and the way our eyes interpret that interaction. Sunlight appears white, but it is actually a mixture of many different colors combined together. These colors include red, orange, yellow, green, blue, indigo, and violet. Each of these colors travels as a wave of energy called a light wave, and each wave has a different wavelength. For example, red light has a long wavelength, while blue and violet light have much shorter wavelengths. This difference in wavelength is the key to understanding why the sky looks the way it does. Surrounding Earth is the atmosphere, a layer of gases made mostly of nitrogen and oxygen. When sunlight enters the atmosphere, it does not travel straight through without interference. Instead, it, it actually constantly collides with tiny air molecules. These collisions causes the light to change direction, a process known as scattering. Scattering spreads light out in different directions rather than allowing it to travel in a straight line. Not all colors of light scatter equally. Light with shorter wavelengths scatters more strongly than light with longer wavelengths. This is wait, because blue light has a relatively short wavelength. It is scattered much more efficiently by air molecules than colors like red or orange. As a result, blue light spreads across the entire sky in all directions, not red or orange or other colors. So, when you look up, you're not actually seeing sunlight directly coming from the sun. Instead, you're seeing blue light that has been scattered by the atmosphere and redirected into your eyes from every direction. This is why the sky looks blue everywhere rather than just around the sun itself. Violet light has an even shorter wavelength than blue light, so it scatters even more strongly. However, the sky does not appear violet for a lot of reasons. These are some examples of the reasons. So first, the sun emits less violet light compared to blue light. Second, some violet light is actually absorbed by the upper atmosphere. That's why we don't actually see the sky appear as violet. And most importantly, the human eye is actually far more sensitive to blue light than violet light, which causes the color blue to dominate our visual perception. The color of the sky also changes depending on the position of the sun in the sky. During the middle of the day, sunlight travels through a relatively short path of atmosphere, allowing scattered blue light to dominate what we see. During sunrise and sunset, sunlight must travel through a much thicker layer of atmosphere before reaching our eyes. Along this longer path, most of the violet and blue light is scattered away before it arrives. This leaves behind longer wavelengths like red, orange, and pink, which creates the colors seen during sunrise and sunsets. The scattering of light also explains why the sky can look different under various conditions like pollution, dust, smoke, or volcanic ash can change how light scatters in the atmosphere, sometimes causing the sky to appear gray, yellow, or even red. After storms or rain, the sky can appear especially blue because the air is cleaner because of the water that falls, allowing blue light to scatter more clearly. The same principle helps explain why space appears black. In space, there's almost no atmosphere to scare sunlight. Even though the sun is shining, there are actually no air molecules to redirect light toward your eyes unless it reflects off an object. This is why astronauts see black space surrounding Earth, even in full daylight. Clouds behave differently from the clear sky. They appear white because they're made of tiny water droplets and ice crystals that are much larger than air molecules. These particles scatter all wavelengths of light nearly equally, causing the colors to blend together into white. Thick clouds can appear gray because less light passes through them. The color of the sky is not the same on every planet. Different planets have different atmospheres, which scatter light in different ways. For example, Mars often has a reddish or pinkish sky due to fine dust particles in its atmosphere. This shows that the color of the sky depends entirely on atmospheric composition and light scattering, not on the sky itself. So, in conclusion, the blue sky is the result of sunlight containing many colors, air molecules scattering short wavelengths more efficiently, and the way human eyes detects color. This phenomenon happens constantly and naturally above us. What looks like a simple blue sky is actually a visible demonstration of physics happening in real time. Every time you look up at the sky, you're actually seeing light that has been scattered by the air around you. It is not paint, reflection, or illusion. It is science at work, quietly shaping one of the most familiar sights on Earth. I think that's all from me. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.